How are you, my friends? This is lecture number 7 of the Calculus 1 course, Basic Differentiation Rules. In the objectives, we see the derivative of a constant, how to find it, the power rule, which is very important, the derivative of a linear combination, and the derivative of a polynomial. The product rule and the quotient rule are two important rules in differentiation. Now, one way we can write the derivative, as we have seen before, f prime of x is equal to the limit of this difference quotient as h goes to 0. Another way we can see the derivative is a function, because we can put f of x, it's like a machine. So f of x, we put it inside this machine in the derivative, we get f prime. So f prime we can write as dx of f of x, which is dy over dx. We have seen the notations before. Now, the rule number 1 here, if f of x is equal to c, c is a constant, it's a number, there is no x, there is no variable. So f prime will be always 0. I put here 5 examples in example 1. Like if the function is 17, the derivative of 0. If it is minus 3, same thing. If it is square root of 2, it's a constant. If the derivative of e is a number, remember the derivative of e is a number, constant, the derivative is 0. If y equals 2 pi, then dy over dx is also. Now, the power rule is one of the most important rule in differentiation. We have f of x is equal to x to the power n, then the derivative f prime will be n times x to the power n minus 1. Just remember that. Now, whatever the power here, we can have a positive exponents. We can apply it like x power 7, t to the power 17, bring it down 17 times t to the power 16. We can have negative exponents like 1 over x. We can write it as x to the power minus 1. Find the derivative of that. We have seen it in the previous lecture. It's minus 1 over x squared, because we bring the minus 1 down, then we subtract 1, so it will be minus 1 becomes minus 2. Also, if we have 1 over x squared, we can write it as x to the power minus 2, so the derivative will be minus 2 over x cubed. If we have a rational exponent like square root of x will be x to the power half, we can use also the same power rule. Now here we have some properties, 4 of them. We can have the derivative of the sum is the sum of the derivatives. We can write it as d of x, a f of x plus b g of x. It will be the derivative of the first plus the derivative of the second, or we can have u is a function f of x and v is a g of x. Then we can write d over dx of this sum. It will be a times du over dx plus b times dv over dx. You can use any formula. Or for any polynomial, you can find the derivative by the power rule. So bring the power here, n times the coefficient here, the leading coefficient, an x to the power n minus 1, etc. for the whole terms. Now let's find the derivative of this function. 83 plus 26x plus 7x to the power 5 minus 5x to the power 9. This is example 3 and the solution together because it's so simple. So this is a polynomial. So we can find the derivative of the first one plus the derivative of the second plus the derivative of the third plus the derivative of the fourth one. And then the derivative of the constant, that's 0. And this is only 26. So here we use the power rule, bring 5 down, subtract 1. Here bring 9 down, subtract 1. So this is the derivative. So easy. Now let's write an equation for the straight line that's tangent to the graph at x equals 1. If I put here x equals 1, it will be 2 minus 7 plus 3 plus 4. So it will be 1, 2. This is the point. So we need this tangent line, the equation. Remember, we have seen that. We need the derivative. So dy over dx, just find the derivative of this polynomial, degree 3. So it will be 6x squared minus 14x plus 3. The derivative of 4 is 0. We have x is equal to 1 given. You see here, given x equals 1. So we can find y is equal to 2. So the point of tangency is 1, 2. So I can use the equation of the tangent line, y minus y1 is equal m. M is the derivative at x equals 1. So I put 1 here. In the derivative, I get m. So the equation will be y equals minus 5x plus 7. Now, one of the important also formula, the product rule. Product rule, we need to find the derivative, as you can see here, the derivative of f of x times g of x. So it will be the derivative of the first times the second function plus the first function times the derivative of the second function. This is what we call product rule. We can write it another way. This is what I normally use, this formula here. It's so easy to remember. I will tell you how. Let's write the function f as u, so we call it u, and the function g of x, we call it v. Now look at the product rule. This is the same, but this is easier in my opinion. uv prime, because u is something, function, v is another function, the derivative now of the product. u prime v plus v prime u. If you try to remember it this way, it will be so easy and nice. u prime v plus v prime u. So you can use that, or you can use this one if you like it. It's up to you. Let's find the derivative of this product. 1 minus 4x cubed times 3x squared minus 5x plus 2. So this is u, and this is v. See, this is u and v. So the derivative will be u prime v plus v prime u. So the derivative of this one first times the second, plus the derivative of the second times the first. The derivative here, you can use the power rule. So this is derivative 0 minus 12x squared. The derivative here also 6x minus 5. Just multiply normal distribution, and then you get minus 60x power 4 plus 80x cubed, etc. This is f prime of x. Now the quotient rule also is very, very important. The derivative of a quotient f of x divided by g of x, it will be the derivative of the first in the numerator times the function in the denominator minus the derivative of the g times the f, all divided by the g of x all squared. Also, I use this way, u over v prime. So if I need the derivative of quotient, u prime v minus v prime u over v squared. Easy to remember if you like. U prime v minus v prime u divided by v squared. Let's apply it here. Z of t, 1 minus t cubed divided by 1 plus t to the power 4. This is a function z in t. Let's find z prime of t, which is dz over dt. This is the same here. Let's find the derivative of this quotient. So I can write directly u over v. And then I write the formula, u prime v minus v prime u divided by v squared. See, 1 minus t cubed, all prime. I put it here in details for you. Times 1 plus t to the power 4 minus, see, minus in the formula, v prime, so 1 plus t power 4, all prime, times the u, 1 minus t cubed. Now you square the whole denominator, all of it. V squared, all of it. Now this one, go to the power rule, minus 3t squared. This one also, 4t cubed. Multiply up, simplify, you will get t to the power 6. You can check it yourself, please. Minus 4t cubed minus 3t squared. This is good answer. Or you can take t squared as a common factor. In the bracket, you have t to the power 4 minus 4t minus 3 divided by t to the power 4 plus 1 all squared. You can leave the answer like this, or you can leave the answer like that. Now, the reciprocal rule, if we have 1 over, remember the reciprocal from the algebra, we have seen 1 over something. So 1 over function, if we need the derivative, we can use also the quotient rule, but now this one is special. So the reciprocal will be the derivative of the reciprocal 1 over f of x will be minus the derivative of the function here in the denominator divided by the function squared. Or you can write it easily, 1 over u prime equals minus u prime over u squared. This is what I normally use. 1 over u prime is equal minus u prime divided by u squared. Let's apply that. Find the derivative of 1 over x squared plus 1. Example 7. So we need the derivative of this 1 over this function. So we can use the reciprocal rule. So it's the derivative, see, minus the derivative of this x squared plus 1 divided by x squared plus 1 all squared. So this is 1 over, this is another way, 1 over u. So this is u now. U is x squared plus 1 minus u prime. So minus 2x, because the derivative of this, derivative of 1 is 0. So that's minus 2x divided by all this squared. That's the answer here. You can do it directly, or you can use this formula 1 over u prime. Now, always please check the playlist, Calculus 1 solved questions, to see more and more questions to understand these lectures better. This is the end of lecture number 7 from Calculus 1 course. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.